4.13 Linear Transformations Notes. Today we're continuing on what we talked about yesterday, where we discussed that if you change the slope in an equation, you are messing with the steepness of the line. But if you change the y-intercept in an equation, you're changing the placement of the line, right? You can be moving it up or down. So today what we're doing is we're taking a more general look. In all of the examples that we're going to be talking about today, we are assuming that when we see f of x, the equation is f of x is just equal to x, right? This is our parent function. It's like saying y is equal to x. So let's go ahead and let's look at this first box on the left. In this transformation, we have g of x is equal to a f of x. What this really means is that our new equation is equal to our old equation times something, right? You see that how that's in the front multiplying? So when we have a number that's in the front, that number a changes the steepness and or direction. Because if that number is negative, it'll change the direction of the line. So I'll put if negative. All right. Now that seems really confusing. So I thought it would be a great example to have a quick example of what that would look like. So g of x is equal to 2f of x. So for instance, if the number a, if that number in there is a 2, then that's multiplying f of x by 2. All right, so this would become g of x would be equal to 2. Remember how we said f of x was equal to x, right? So if I'm saying that I'm multiplying it by 2, then really I'm getting 2x, right? So this would become steeper. So I'm just going to put becomes steeper. Basically, if this number is bigger than 1, it's going to be getting steeper. So by that same logic, if I have f of x is equal to 3/4 f of x, in other words, a number less than 1, then it's going to become less steep. Okay, so to summarize, if you have a number that's multiplying f of x, it's changing steepness. A bigger number will make it steeper, and a number less than 1 or between 0 and 1 will be less steep. All right, next, g of x is equal to f parentheses b of x. Okay, so again, right, we have a number right here that's still multiplying, right? It's still a multiplier. So it's still changing steepness. All right, it's changing the steepness of our line. Or possibly direction, kind of like we said before, if it's negative. Okay. Same thing as before. So if I have a number, but it's inside the parentheses now, but it's still a multiplier, if it's bigger than 1, for instance 5x, then we're going to say it becomes more steep, right? Steeper. And if that number is less than 1, like a 1/4 here, and it's going to become less steep. So what I want to do right now is I kind of want to summarize both of these boxes here because they have similar conditions, right? Similar rules. Okay, so we're going to say if the number is multiplying, it changes steepness. All right, if the number is multiplying, it's changing steepness. It's either going to make it more steep or less steep. If that number in the front is a negative, it changes the direction of the line. Let's look at the last two boxes. Here we go. So in this case, we have C and we have D. So what I would like for you guys to notice is that this C is inside the parentheses. And the next one, however, this D is outside the parentheses. That's huge. That's a huge distinction that I need you guys to make. All right. If we are no longer multiplying, then we're no longer changing steepness. So if we're not changing steepness, what are we changing? We are shifting our graph around, right? We're moving things. So I'm going to say this. If the number is inside, then we are shifting our graph left or right. Okay? If that number is outside, then we are shifting our graph, but we're going to shift it either up or down. So the placement of the number is how we decide if we're going left or right versus up or down. I want to do the last one here first. So I'm going to focus on this box here for a second. If I have an example, right, here's my example of this thing. G of x is equal to f of x plus 1. All right, so this 1 right here tells me this is going to shift my graph up 1, right, because it's a positive. A positive makes it shift up. So what's going to happen when I have f of x minus 3? Well, you might have already guessed, since it's a negative, we're going to shift down 3. I really like this because the signs are just what you would expect them to be, right? A plus is going up and a minus is going down. However, when we look at the c value, the number in parentheses, it's actually backwards from what we would think. And I want you guys to really understand why. Let's look at the bottom example here real quick. All right. So if my example says f of x is minus 8, all right, x is minus 8. Sorry, let me compare this to the original formula. Wasn't the formula f of x minus c? So what is c? What is c? Take a look here. We can do x minus, right? This was part of the formula. X and the minus were part of the formula. So really, c is equal to 8. Right? Really, c is equal to 8. Well, that's a positive number. 8 is a positive number. C is a positive number. That means we are shifting right 8. Okay, we're going to actually shift right 8 here. Now, that does seem backwards from what we would expect, because I think that when we see this minus 8, we would think to go left. But because the minus is part of the formula, then we do the opposite. So I'm going to write here negative in formula makes opposite. All right, because the negative is in the formula, it makes opposite. That kind of makes sense when you think about how this was a positive, so we just did what we thought we would do, right? But here, this negative means we're going to go opposite. So in this case, right, I'm going to go, since I see a plus 2, I'm going to go left 2. All right, so this one was definitely the weird one. So let's go ahead and let's summarize what we did in these last two boxes. We did not change steepness this time, right? We changed direction, right? We changed the, not direction, the placement of the graph. And so let's summarize this. I'm going to say if adding or subtracting a number, then we shift the line. Okay, so let's compare that. Multiplying, when the number is multiplying, we're changing steepness. When the number is being added or subtracted, we're shifting the line somehow. Let's get some good examples going here. I think this will help. Let's go ahead. This is probably more like the verbiage of a test question here, like in example number 1. Describe the effect on f of x if g of x equals 4f of x. Please notice that this is a math problem, and there is literally only one number, and it's this 4. And you're supposed to know that this 4 is multiplying. And so you know that means it's going to change steepness. So if it's a number bigger than 1, that we're supposed to know that this is going to make our line more steep. It's going to make it more steep. So drawn below is my original parent function line, right? So a steeper line than that might be something like, oh, maybe like this. That's definitely a steeper line. Okay. On the next one, let's go ahead and let's look. This one is saying that we have g of x is equal to negative 1/2 x, f of x. All right, right off the bat, this negative means that we're going to go in the opposite direction. All right, so this positively sloped line would now become a negatively sloped line. Let me erase this here. Okay, so then we have this 1/2. Well, what does this 1/2 mean? Again, it's multiplying, so we know it's going to change steepness, but because it's less than 1, this one is going to be less steep. This one is going to be less steep. So for instance, a graph of this one might look like that. Might look like that, right? It's going the opposite direction and it's less steep than the original. Okay. Let's go ahead and let's look at the next two. The next two says write an equation for f of x if it has been translated 2 units up. So I'm going to focus on this last part where it says translated 2 units up. Okay, translating up. So that means it's not multiplying, it's being added or subtracted. So in my new equation, I'm going to call it g of x. Well, what do I do to make things move up? Oh, I put it at the end, right? I put it at the end. So let's go ahead and let's say my new equation would be my old equation, f of x, but 2 units up, and we're going to do a plus 2. All right, so 2 units up make me go up plus 2. Here's my line. Probably looks something like this, right? We just shifted it up. We didn't mess with the steepness at all. And the last equation is similar to this one. It's asking us to write a new equation that's been shifted down 4. All right, well, again, up or down, that's just going to be a number at the end. So my new equation, g of x, is going to be my old equation, f of x, but we're going to shift it down 4. So we put a minus 4 at the end. And that signifies, since it's at the end and it's negative, that it got shifted down 4. So something like that. Okay? All right, that is the lesson today in a nutshell here. Please just keep in mind, if the number is multiplying f of x, it's changing the steepness. If it is being added or subtracted to f of x, it's changing the position, right? It's moving it, most likely moving it up or down, possibly left or right.